Hello students, welcome to Chemistry with Hifras channel. In this video, we can learn how to figure out oxidation number of elements in different compounds. What is oxidation number? Right? Oxidation number is the charge assigned to an atom of a molecule or of an ion. Okay, today I am going to tell about some rules and regulations. How can find oxidation number easily? There are some tips, there are some rules. So if we use these rules, well, we can easily find any oxidation number. Okay, so rule number 1, elements by itself 0. Elements by itself 0. What is elements? Okay, first we can take sodium. It is an element, so sodium is 0. Carbon itself, it is 0. Cl2, yeah, it is also an element, so it is also 0. So first, elements by itself, it is 0. S8, there are 8 atoms in S8, but sulfur itself, it is 8 atoms combined in S8, so it is also 0. P4, phosphorus 4, it's an element, so it's also 0. Okay, understand? Now second rule, hydrogen is always +1. So there are some exceptions, but here only one exception. Okay, in this case, except in metal hydrides. Metal hydrides means sodium hydride, magnesium hydride, MgH2. Those are metal hydrides. In metal hydrides, hydrogen is -1. Here, -1. Hydrogen is -1. We can understand this very clearly after other rules. Okay, right. Group 1a. Group 1a means, you know, lithium's group, always +1. So if we take lithium, sodium, potassium, rubidium, cesium, each and every element will take +1 in its ion. Sodium plus, potassium plus, rubidium plus. In elementary state, it is 0. Lithium 0, sodium 0, but in ion state, it will take +1. Okay, understand? Fourth, group 2a, always +2. What are the elements in group 2a? Beryllium, magnesium, calcium, strontium, barium. Each and every element will take +2. Okay, in elementary state 0, in ion state it will take +2. Beryllium +2, magnesium +2, calcium +2, they will take +2 oxidation number. Right. Fifth rule, halogens always -1, but positive with oxygen. Why we are telling like that? Why halogens positive with oxygen? Okay, because in electron negativity series, oxygen is in front of halogens, right? So oxygen's electron negativity larger than chlorine, bromine, iodine. Then what about fluorine? We will talk in next rule about fluorine. So we are considering as elements here chlorine, bromine and iodine. Okay. So halogens always -1 except with oxygen. Okay. Right. We'll take both examples in this part. Okay. See, in HCl, hydrogen I told always +1. I didn't talk about that before. I am talking here +1. Then chlorine -1. In NaCl, we know sodium always +1. Chlorine also always -1. Okay, but in this condition, we know about that. So, I am taking another example, cobalt chloride. So you did know about cobalt. Okay, so here, right, okay, I will not cobalt chloride because it is over. So now we will take CuCl. Okay, CuCl. Here, chlorine -1. Then copper +1. So we can talk easily. Okay, right. Next rule is fluorine always -1. Okay, fluorine always -1. If it come with OF2, yes, it is -1. Fluorine will be -1. Okay, this is the rule. We'll see. Okay, next rule is oxygen always -2 except with fluorine +2. Okay, in OF2 +2 we know, right? Next one, in peroxide it will be -1. Another case, they are superoxide. Here in this case it is -1/2. We can tell oxide as -2 or 2 minus, but in peroxide O2 2 minus, in superoxide O2 minus. Okay, sodium plus, we will take potassium. Okay, potassium plus O2 minus, we will say K2O. Here in this case potassium +1, oxygen -2. Then K plus O2 2 minus. Then we can say K2O2. Potassium peroxide. Here potassium +1 but oxygen -1. Okay. Then we can say K plus O2 minus. Here -1/2. K +1 O2 -1/2. Then KO2. This is called potassium superoxide. Okay. This rule I applied in lot of places before, but we are officially studying here. Rule number 8. Sum of oxidation numbers for a neutral compound is 0. If we take one neutral compound AB, okay, then we have to say A plus B, oxidation number 0. Sum of the oxidation number is, if we add A plus B, it is 0, equal to 0. Okay, and if we take AB2, A plus 2B equals to 0. Okay, this is the case. Right, now I am talking about cobalt chloride. Okay, so we don't know about this cobalt. Now I am going to calculate cobalt's oxidation number. So I will take this number as X, and chlorine to chlorine, we know chlorine always -1. There are two chlorines, so we'll put 2. Okay, after that it is equal to 0. Then X equals to +2. In this case, cobalt oxidation number is +2. Okay, so another case we'll see. K2Cr2O7. There are 2 potassium, 2 chromium, 2 oxygen. 7 oxygen. In this case, we knew about potassium's oxidation number. It is 1A, group 1A. So it is +1. 2 into +1. We didn't know about chromium, so we'll take 2x +7. We already knew oxygen. It's -2. So total equal to 0. So 2 plus 2x minus 14 equal to 0. 2x equal to 12. X equals to 6 plus 6. So in this case, chromium's oxidation number is +6. Okay. Next, this is the last rule. Sum of oxidations of polyatomic iron is ion charge. If we take AB minus, it will be A plus B equals to minus. AB equal to 2 plus, A plus B equals to +2. Okay. Now we'll take Cr2O7 2 minus. What is the oxidation number of chromium? Okay. So we don't know about that. So 2x plus -2 into, we knew always oxidation -2 except peroxide, superoxide. So here -2. Okay. -2 into 7 equals to -2. 2x minus 14 equals to -2. Sorry. Okay. So 2x equals to -2 plus 14 plus 12. X equals to +6. This is how we need to determine oxidation number in polyatomic ions. Another one, MnO4 minus. Okay, we don't know about X, Mn, so I will assume that is X. And here -2 into 4 equal to -1, no? This is the charge of the polyatomic ion. So here X -8 equal to -1. X equals to +7. This is how we have to determine oxidation number. Clear? So we will talk more in the next session, in next video. If you like this video, please subscribe.